All right, we're on. So today we're going to be talking about an app that I built recently called Cancel Me. It's an app that lets you look through all your past tweets and then it tries to flag any that are not safe for work or could potentially get you canceled. So the structure of this video, we're just going to walk through some of the main features, and then after that, we're going to dig a little deeper and go through how it was implemented and what technologies were used. All right, so first thing up is we're able to log in with Twitter. This is going to redirect us to the Twitter sign-in page. Take us back to our app on the dashboard. We can view all of our tweets that we were able to get off of the Twitter API. Each row will link to a tweet. We can also delete that tweet. And when we refresh on Twitter, it'll be gone. Again, another link. So next up, we have this profanities tab, and that's going to show you all the tweets that could get you canceled. We have an upload button, so you can request your data archive file from Twitter, and then this will allow you to upload all of your tweets into the app, and you can choose which ones you want to delete and analyze every single tweet you've made to date, and then categorize them as either whatever's going to cancel you and then whatever's safe. So again, we can choose to delete one by one, or we can select multiple. You also see at the top, we have this little scorecard that categorizes the level of our tweets. We can share our scorecard on Twitter, and this will take us to our score page. So if we click on this, it's going to show us our score page. We can also search. So right here, I'm going to search for Rihanna. Don't worry, it's not going to show any of Rihanna's tweets. It'll just show her scorecard. And then just a little text placeholder for whatever level was. You can also donate through Stripe to unlock some of the premium features. Not going to do that now. And then last, we have a score page where we can see everyone who used the website. Again, you're not going to see their tweets, just their scorecard and whatever title that they got for their score. So Devout Mormon's the best, and then there's a bunch of others you can get. All right, so first piece of technology we're going to go over is what was used to create the front end. So I chose to use Solid.js as the library to build out the UI, and then Solid Start, which is their meta framework to control things like routing, session storage, and cookie storage. I will say that this warning is definitely spot on. There are things that are missing in the documentation. Kind of like low-level explanations of how specific methods work, such as like create server data or create route data. And I didn't encounter any bugs. There are workarounds for things that I had trouble with. But I will say that it's still kind of early days for this framework, but that shouldn't stop you from trying it and seeing what you like about it. I had to try this mainly because of how small it is. It is like so incredibly snappy because of the usage of signals. So instead of like doing what React does, where it re-renders the entire like DOM tree, it's Solid.js is only going to like re-render specific tags. So usually like React will like re-render an entire component if some type of prop changes. But Solid.js is like so fine-grained that if you have like a p tag, right, and there's like some text signal that you have, it's only going to update that, and it won't re-render your entire component. So you get a lot of great performance benefits out of it, and it's much smaller amount of JavaScript shipped to the client. So you can see right here we have 20 kilobytes. React 130 just for React DOM. That doesn't include React. I mean, I don't think it's that much, but okay, yeah, like 6, so it's not that much. The one complaint I have is the documentation, which they've already pointed out in their docs themselves. So to kind of paint out with this picture, I was trying to create a Twitter card, right, for a specific page. So everyone has their own score page, and I was thinking, okay, I really want the Twitter card to be this area right here, like this card showing their metrics, right? It's kind of like a cute, fun little design. You got bars, things are categorized for how many tweets you had that were not safe for work, how many were safe. So I really wanted to use that as the Twitter card. You can see that that is not what it looks like at all. I mean, it looks like garbage. I just straight up like just chose to not even worry about it. I was like, I give up. I can't figure it out. But basically, this Twitter card takes you to your score page, right? And I wanted it to be this dynamic image. So what I was trying to do was create a dynamic image tag, or a dynamic image, and then put that into the dynamic meta tag. So you can see right here we have this Twitter image, and it basically takes a URL to some type of PNG, JPEG, whatever. And so my idea was I could use a library called HTML to image. So it just takes a block of HTML, turns it into an image, and then you get a data URL back, and you can use that for, you know, whatever purpose you have. So I had this function, generate image right here, and basically what it would do is it would look for this element, try to generate the image when it exists, and once it does, we get this data URL, and then I was going to set that in the meta tag. And then I was going to reference that in this meta tag right here. The docs for the dynamic meta tag are like very lacking, and I could not figure out how to get it. I had to like look through GitHub discussions and pull requests and issues that people had posted on the repo, and I just couldn't get it to work. So I said, you know what, forget it. I'll just upload this to S3. So I have an endpoint that does that every time you are fetching your Twitter score, and then we're just going to upload that to S3, and we will use that in the Twitter image card. Also wanted to mention that for the CSS, we use Tailwind, and for doing the icons that are on the site, we use the Hero Icons package, which is actually built by the Tailwind team as well. And you can see it's pretty easy to use, nothing super crazy, just using the inline classes. And then for the icons, we just have a regular icon component. I wanted to quick go over how the authorizing with Twitter functionality works, because it really confused me at the beginning and I had no idea what I was doing. So in order to log in with Twitter, it uses something called OAuth, which is an authentication flow that allows you to just verify that a user is granting access to your application, and you can make requests on behalf of that user. So the first thing we have is when you click the login button, it's going to execute this login function. We have an API route right here for logging in. And what this does is we use a package called Twitter Lite. And Twitter Lite basically just has a bunch of helpful wrapper methods around Twitter's API. So the first thing we need to do is get a request token. Now, the request token is basically us telling Twitter, hey, I'm going to try to authenticate this user and let them sign in on your platform. Here's the token for that request. So we give them the token, and we return this URL that the client then uses to prompt them to sign in. So this gets returned, and then the client gets the URL, and then it says, okay, window, go to this URL and let the user sign in. After the user is done entering their login information, it goes back to a callback function on our app. So I believe this redirects to the dashboard as the callback URL, but basically what this does is Twitter now has said, okay, this user let you verify, or this user has verified on your app, and now we can get something called an access token. Now, the access token is going to allow us to actually create a client on behalf of the user. So for instance, when someone logs into the app, we want to be able to delete their own tweets. And in order to do that, they have to make the request to Twitter, because you can't just delete someone else's tweets, right? That would be like a terrible bug in the system. So that's what we're doing here. We're getting an access token so they can use the Twitter API and our app can know about it. And then this is just some extra stuff we're doing. We're creating a user session to get some cookie session storage so that there's some state attached to these requests, and we know who's making the requests. And then whenever they want to log out, we simply just call this logout function, which destroys the session and removes the cookies from the request headers. So another cool aspect of this product are paid features. We have an upload and a search feature that are all only enabled if you make a one-time donation. So I've got some logic here on the front end that determines whether or not you donated. In order to donate, you go to this donate page, you click checkout, and then it takes you to this Stripe page with this form where you can make a one-time donation. So in order to do this, you can see I canceled it. So we've got a little callback here to let you know that it was canceled. In order to implement this, we use two things. We use Stripe and Prisma. The first aspect to get to that checkout URL is actually really simple. So when they go to click checkout right here, they're going to hit this endpoint, and we're just going to get a couple of things. We're going to get whatever the email, the product ID, and the user ID is. We're going to find the Stripe product associated with the product ID. There's only one product here, so we're just going to always pass in the same ID. And then we're going to create a checkout session, and that checkout session is going to redirect us to the Stripe page where they can fill out their details and submit a payment. Now, in order to actually know whether they completed the payment or not, we need something called a webhook, because this endpoint is just in charge of redirecting them to the correct session page. This is all code handled by Stripe. So after they make this, we're going to have no idea whether they donated or not. So in order to do that, we have a webhook, also implemented through Stripe. And it just does a couple of really simple things. So it listens for events, one. It does some validation here. If it's not a post method, then we just flat out ignore it. If it doesn't have a Stripe signature in the header, then we flat out ignore it. After that, if we have those two things, then what we're going to do is get something called a signing secret. This is set up on the Stripe dashboard after we kind of have registered our website with them. And it's a secret that only the app and Stripe know about. So we can use that to verify that the event actually came from Stripe. So right here you can see we're passing in some parameters just to execute this verification algorithm and make sure that the events match to what they should match to. So if that fails, we're going to throw some Stripe errors. We got some TypeScript up there handling that. And then we're only going to listen to one event because we only care about one. If they completed the checkout session, then we know that they donated. And in order to keep track of that, we're just going to save it to the database. So we use Prisma. Just add this to the donation table. If they have an existing donation, then we're just going to forget about it because we only need to keep track of one donation. And then if that all goes through, then we will add this to the database. And then on the front end, we'll be able to know if it's a premium user. So let's see if we can quick find this. Is premium user. So you can see right here, I'm just querying Prisma again to see if we actually got the donations. So there's just a few more tools I want to go over before we close this video up. The first is Docker containers. I use a Docker container in order to locally serve my Postgres database server. So if we look in my package.json, you can see we got two commands here for our dev. We run the dev flag, which runs our Postgres Docker container, and then our solid start UI server. So this is a great way in order to easily get a database up and running on your local machine. Just create a Docker container. The next thing I want to go over is Cloudflare tunnels. So I ran into an interesting problem where I was trying to test my Stripe webhook locally, but it only accepts HTTPS for the webhook. You can't use localhost. So in order to do that, we can forward our local host URL to a HTTPS URL. And you can accomplish that with Cloudflare tunnels. If you're familiar with ngrok, it's basically the exact same thing. So ngrok generates this HTTPS URL for you, and then it'll forward it to your local machine. So I have my dev server running right here. Gonna clear that. And then I also have my Cloudflare tunnel configuration set up, which is aimed to listen on this HTTPS URL. It's mapped to this URL. So we're gonna quick test this, and we're gonna see that my local machine is going to get the request from Stripe. So we're gonna do a sample donation, see that this goes through, our donation is complete, and then we're gonna go to our Stripe dashboard. 835 just came in, and if we look for the name, we can see that it was sent the Cloudflare tunnel request to this HTTPS URL. And if we look in our events, sure enough, we have gotten the event with Cloudflare tunnel. So this was a great way for us to test our Stripe webhook event and not be bogged down by the limitations of localhost. Another one I wanted to go over was ChatGPT. So if we look at this quick snippet, this conversation that I had with ChatGPT, I was having a lot of trouble with creating the Stripe webhook, and so I just copy and pasted my code, and the chatbot was smart enough to actually understand the Stripe API library, and it quick gave me the literal code to fix the error I was encountering. I also used it on how to create a fave icon, privacy policy, and then a sample terms of service just based off of a really small prompt. So that about wraps it up. That's how I built Cancel Me. It is deployed on Vercel, I forgot to mention that. And in a future video, we'll be going over how I created Modeler's Rift, which is a website that allows you to view League of Legends models in the browser. All right, Odin, say bye. Thanks for watching, and we'll see you next time.
Say goodbye, buddy.